Hello, today we consider the following problem. Given are three-digit number with non-zero digits, such that a squared plus b squared equals c squared. We need to find the largest possible prime factor of n. Before we start, I would like to remind you that any three numbers which are integer and satisfy to this equation form so-called Pythagorean triple, which can be denoted as here, and the name is after ancient Greek philosopher and mathematician Pythagoras, who lived approximately 2,500 years ago. Hard to believe, this guy made discoveries which we are using now, more than 2,500 years after his death. Of course, you recognized that this equation is a so-called Pythagoras theorem, which relates the sides in a right triangle. In our case, A, B, C are one-digit integers, so they are restricted between 1 and 9. Let's discuss how we will proceed. The simplest way is to identify all such numbers and then factorize them and find largest possible factor. The question is how to find them. We don't know the rule, how many integers we can find for this case. So the simplest way is to inspect each possible combination and then select all which satisfy this equation. It's not so difficult as it looks like, because numbers are restricted to a small interval, and we can do this without calculator, which is prohibited in Olympiads. Now we will go to solution itself, and we start with step 1, where we will find all possible Pythagorean triples ABC which satisfy this equation. Technically, we will use the table. This is a header of this table. We will analyze all possible combinations A and B, calculate A squared plus B squared, and inspect if this combination will give us the square of one-digit integer. As an example, I will take here A equals 3 and continue with B from 1 to 9. We take B equal 1. A squared plus B squared is 9 plus 1 is 10. 10 is not a square of integer, so we cancel it and go to B equal 2. Here we will have 13. Again, it is not what we are looking for. 3 will give us 18. We should continue. 4 gives us 25, and here we see that we have a square of 5. So A equals 3, B equals 4 provides here C equals 5. And as a result, we have here first Pythagorean triple, 3, 4, and 5, which provides the first number, and 1 equals 345. Simultaneously, we can switch here 3 and 4 and get another solution for A equals 4, B equals 3, C equals 5, because A and B here are symmetrical. It provides next number for 35. And then we continue analysis of other values of B. 5 gives us 34, not a square. 6, 45. 7, 58. 8, 73, and finally 9 is 90. So here we got this solution, and from this solution we derive this one. Then we continue such analysis for all other combinations of A and B. I will not do this, it is very simple, but just give you the answer. Beyond this number, this analysis provides no other solutions. So we have only two numbers, 345 and 435, which we need. Next, we should go to the step 2 and find the largest possible prime factor of these two numbers. But before doing this, because we did a good job, we will analyze one more triple, which is not Pythagorean triple, but it is important. It is like, comment, subscribe. And after this, we go to the step 2, where we will factorize n1 and n2. n1 is 345. The number ends with 5, so it is divisible by 5. We represent it as 5 times 69. 69 evidently is divisible by 3. We have 5, 3, and 23. 3 prime numbers. The largest is 23. We keep it here. And go to the next n, which is 435. Again, it is divisible by 5. It's 5 times 87. 87 is divisible by 3 again. And we have here 5 times 3 times 29. Largest prime is 29. Here we compare these two numbers. 29 is the largest. So the answer in our problem is 29. The problem is solved completely. If you have another solution, please leave a comment and we will discuss this solution later. And finally, if you like this video, please leave a like, comment and subscribe for the channel.